Welcome to Ask and Learn.
Okay, so we need to count how many bit strings with length not exceeding n, where n is a positive integer, and consisting entirely of ones. And of course, we don't need to count the empty string. So what this means? Well, basically we have some fixed value n that is positive. Okay, so this value is fixed, and then we need to count how many bit strings of that not exceed this length n, and is composed full of ones. So let's in this case let's suppose that n is some number. So we start with the bit string 1. Okay, then the other one will be 1 1. So I'm going to put here the length, and here you're going to put the string. So we have length 1, length 2, length 3, until length n. So the fact that these strings consist entirely of ones, that make the things easier, because for each of these lengths we have only one bit string. So for length 1 we have 1, for length 2 we have 1 1, for length 3 we have 1 1 1. So there is only one choice for each of the possible lengths between 1 and n. And for the length n we have 1 1 1 1 n times. So you can see that for each of these lengths we have one bit string, and we need to count how many bit strings. So you can see that for each of these we have 1 1. So the total number of lengths is going to be the total number of possible lengths between 1 and n, and that without counting the empty string, because the empty string will be the 0 and here will be the empty string. We are not counting this. So you can see that between 1 and n we have n possible lengths. But here we found a one-to-one relation between the lengths and the strings, because there is only one possibility for each length. So that means that the possible strings, that the number of possible strings will be determined by n, and it will be n. It only depends on the number that we fix for the maximum length of these strings.